Hey guys. All right, today we are going to cover Unit 4, Lesson 6, and this is application of domain range. So go ahead and open your journals, pause the video if you need to, and we're going to update our table of contents. So we should have Unit 4, Lesson 6. We're going to call this, I guess we're just going to call it domain range. Domain and range. And you can link that, highlight it, click your little paperclip button up here, slides in this presentation, link to slide 17. Pretty sure that's right. Yeah, slide 17. So we're on slide 17. Okay, so pause that, go through each step if you have to. All right. Okay, so here we go. We've been dealing with word problems the past few days. We've learned how to write equations. We've learned how to interpret the slope and y-intercept. And so now we're going to learn how to talk about the domain and range from word problems. And we've learned how to do domain range. We talked about domain range in our last unit. So we're just now doing a real world application of it. Okay, so here we go. We have a plumber. He charges a $50 fee plus $100 per hour to complete a plumbing job. The total amount spent on the plumbing job can be expressed by the function T of x equals 100x plus 50, where x represents the number of hours spent on the job. The maximum time spent on one job per day is 8 hours. Find a reasonable domain range for this situation. All right, so my first question here is what values of each variable can make sense for the situation? So x is going to represent the number of hours that we spent. So what's the least amount of hours that he can spend working? Well, 0, right? He can just not work at all. Make zero hours. And the most amount he can spend, it says that he can't spend more than 8 hours per job. So 8 hours per day. So for one day, he can work no hours, or the most amount is 8 hours. So what are some values in between there he can work? Well, he could work maybe 1 hour, or he could work, let's say 2.5 hours, right? He could work for 2.5 hours. We could figure out how much he costs, how much he would have to be paid for that half hour. What about like 3 3/4 of an hour? 3.75. What do you think? Like 3/4 an hour, maybe? Or like 6 hours? Maybe he worked 7.15 hours, right? He could work just parts of an hour. He doesn't have to work a whole hour. He just work parts of an hour and get paid for just that part of an hour. Okay? So then what could my y values be here? Well, I have a function, so I'm going to use Desmos to figure out those y values, because on this unit, I want us to know domain and range on this lesson. I want us to understand domain and range, so I'm not really too worried about being able to plug those in and solve right today. So I'm going to use Desmos to do this more quickly, and I'm going to show you this nifty little thing Desmos does. If I can get to the right thing. Here we go. There we go. All right, so my function is T of x equals 100x plus 50. So in Desmos, I can type in, I have to change this to f of x equals 100x plus 50. And then right here, I think so all I did was click this little settings button. And then if I click this table, I can convert it to a table, and I can plug in my values. So here I already have a 0. So when it's 0, when my x value is 0, my y value is 50. So on my notes over here, I can type in at 0, it's 50. At 1, let's see, we did 0, 1, what else did we do? 2.5, 3.75, so 2.5, I can just type in my x values, 3.75. I think we did 6, and we did 7.15 and 8. 15 and 8. Okay, so I'm just gonna, I don't know if I can delete these off. Oops. 8. There we go. Okay. So at 0 hours, he's going to make $50. At 1 hour, he is make $150. At 2.5 hours, he makes $300. So I can plug this table in over here. So 150, 300, 425. 150, 300, 425, 650, 765, and 850. 650, 765, I think, and 850. Okay. So this is the amount of money he's making per hour he's working, right? So based on the number of hours he's working. So I want us to think back a couple units ago, we talked about whether things were discrete or continuous. And if we had things where they were just single points on a graph, single points, individual points, they were just random points, we said they were discrete. They didn't have lines connecting them. But if we had something that had lines connecting it, we called that continuous. So would this function, would it have just points, or would we have a continuous function? Would they all be connected somehow? Well, the way I want to think about this is, can I only work for 1 hour and then 2 hours and then 3 hours? Those would be individual points. Or can I work for time in between 1 and 2 hours? Can I work for 1.5 hours, 1 3/4 hour, 1 3/4, 1 1/4 hours? Like 1 hour and 52 minutes. Can I work for almost 2 hours, but not quite 2 hours? So what can he do? Can he get paid based on the exact number of minutes that he's working, or is he only getting paid for an hour and then 2 hours and then 3 hours? Well, as somebody who would have to pay a plumber, I wouldn't want to have to pay them for 2 hours if they only worked for an hour and a half. I would only want to pay them for the time they're there. So this this would be a continuous function because we could change his pay based on the exact number of minutes, even if we wanted to go down to seconds, be really picky about it, based on the exact number of minutes that he worked. Okay, so we would say this is continuous. We'll see a problem in a second that's discrete, okay? So how do I write my domain? Well, my domain, remember, is x values. My range is my y values. So I'm talking about my x values. So the lowest x value that I can have, the least number of hours he can work is 0. He can't work anything less than 0 hours, right? And then the most number of hours he can work is 8 hours. So this is how we write continuous functions. So it would be 0. We need to figure out, is it going to be less than or less than or equal to? So can he work 0 hours or can he not work 0 hours? Well, he can. He could just go out and give him an estimate and not actually work, right? So he can not work. So since he can do that, we're going to have equal to. And then he can work 8 hours as well. So again, we're going to have an equal to. We're going to take out those less than, just equal to. So we have 0 is less than or equal to x is less than or equal to 8. And this means that he can work any time, hours or minutes, between 0 hours and 8 hours. Okay? So then my range, well, how much would he make? What's my y value when he works 0 hours? What's the least amount of money he can make? Well, the smallest amount of money he can make is $50. And can he make that amount? Yes, he can. So it's going to be equal to. Then it's the same thing up here. Yes, he'll be able to make the most amount of money. So again, we have equal to. We're going to keep our equal to sign there. And the most amount of money he can make, well, the most amount of hours he can work is 8 hours. So the most amount of money he can make is $850. $850. Okay? So you really want to think about this. These type of problems are really like logical. Just think in real life. This is like, what would you do? So I like to say that application problems are really kind of like your street smarts. Okay, you may not completely 100% understand all of the academical, the mathematical side of it. But if you can think through it, if you can use your street smarts and think through it, then you can do these problems, okay? So if you're street smart, you got this. You can handle this, okay? All right. Number 2 here, we have Joanna has $250 in her account and withdraws $50 each month. The function v of x equals 250 minus 50x. So she's starting with $250 and she's taking out $50 each month. to represent the total cost. So this will total amount. This will be the total amount in her bank account after X months of withdrawals. State a reasonable domain range for this situation. Okay, so what variables make sense? Well, let's start at the beginning, I guess. Let's see. We have $250 in her account. So I think first I want to take my function. I'm going to type it in Desmos and get my table. Let's get an idea of what's happening. So I'm going to change this to be, I'm going to write this as f of x instead of v of x. 250 minus 50x. So f of x equals 250 minus 50x. Was that right? 250 minus 50x. Okay. And then I'm going to click my settings button. I'm going to convert it to a table. Okay, so how much does she have at the beginning? Well, the beginning means how many months have passed at the very beginning? None. So 0 is the beginning. Then we could go 1 month and 2 months, 3 months, 4 months, 5 months, 6 months. Now I've got a negative number. So can we have, in most situations, in a savings account, can you get a negative balance? No. In a bank account, maybe they give you a little bit of overdraft. But in a savings account, they're not. I mean, a checking account, they might give you overdraft, but a savings account, they're not going to let you overdraft your savings. They're going to be like, no, you can't take that money. So will she have 6 months worth of money to spend? No, she won't. So we don't even need 6. So at 0 months, she'll have, at the very beginning, she does have $250. And then at the very end, she's got $0. So I think we can go ahead and fill in our table. So we'd have 0, then we had 1, 2, 3, 4, and 5. And I'm going to go ahead and put 6 on here just because I want to be able to see what happened here. Let's add 6 back on here. Okay, so that went $250 and it went down by $50. And it's going down by $50 each month. So back over here on my table, we started at $250 with 0 months, and then 200, and then 150, and then 100, and then 50, and then 0. And then if I would have gone 6 months, that would have given me negative 15. So I want to think about, first, is this discrete or continuous? Well, she was taking out $50 a month, each month, right? She wasn't taking out $25 in between the months. She just was doing $50 each month, and that's it. So these are going to be points. The first month she's got this month. The next month she's got this month. Then she's got this month. She's not taking out little tiny numbers, little tiny amounts each day in between. She's just doing it once a month. So since she's only doing it one time each month, these are just set amounts. We don't have anything in between. So since we don't have anything in between, this is discrete. And what's a reasonable domain? So when we have discrete functions, remember we have these little brackets and we just list out our x values. Well, 0 is reasonable. She can just never start taking money out. Then she could do it for 1 month, and then 2 months, and 3. She could do it for 4 months and 5 months. At 5 months, she would have $0 left. So is 6 a reasonable number to put in there? It's not, because that would give her a negative balance, and they're not going to let her spend their money, right? The bank's not going to let her spend money that she doesn't have. So 6 months is not reasonable to type. So then my reasonable range are my y values. So she starts with $250, that's reasonable. Then she could have $200, she could have $150, she could have $100, she could have $50, or she could have $0. Did she have that negative 50? No, the bank's not going to let her spend $50 that she doesn't have, so it's not reasonable. Okay? So this is what continuous function looks like. We would count everything. This is saying we're talking about 0, 0.1, 0.2, 0.3, all the numbers in between 0 and 8, and all the dollar amounts between 50 and 850. Here, we're talking about just 0 months, 1 month, 2 months, 3 months, 4 months, or 5 months, and just these certain amounts. Okay, we're not talking about the numbers in between 250 and 200. We're just talking about 250 and 200. Okay. So next thing, there is an assignment. So go to modules, Oh, yes. Okay. Get to the right thing here. Oh my goodness. Domain and range. And I'm going to click preview. You're going to start quiz. There is a matching activity. So what you're going to do is you're going to read the activity, read the word problem, and you're going to match it to one of these domain and ranges. Okay. My bell is fixing to ring and I'm going to have students coming in. So I'm going to make another video and I'll post it on to the top of this assignment that you can click to help you with a few of these problems. All right. Y'all have a good day.